some more specific notes on greenhouse gases. So that's what we're here to do today. I just am going to give you a couple of quick things and then we'll be on our way. So you read some stuff, you've watched some videos, but just a little bit more formal information about greenhouse gases. And I'm lazy, so I'm just going to call them GHGs for short. Okay. And as we've talked about a little bit in class, greenhouse gases are just specific or certain gases that are in our atmosphere that, because of their molecular makeup, okay, they trap the heat of the sun. Okay. As a result, we have this thing called the greenhouse effect. Okay, which is basically the rise in temperature that the Earth experiences due to the greenhouse gases. Okay. How does it work? So basically, if we kind of look at it kind of big picture here, how the greenhouse effect works. We've got the sun. We've been talking about the sun for a long time. So here's the sun, way out 8 light minutes away from the Earth, right? And it is going to give energy. It's going to send energy down in the form of high energy radiation okay, that passes right through all of the greenhouse gases. So step one, we'll say that sunlight enters the Earth's atmosphere. Okay. As small wavelength or you could say high frequency waves that pass through the greenhouse gases. That's all well and good, okay? The deal is that those high energy waves are absorbed by the Earth's surface. So step two, the high energy radiation is absorbed oh my goodness, this is ridiculous, by the Earth's surface. Okay, so it goes in, and then the Earth re-emits the energy back into the atmosphere. So that's step three. The energy, though, that the Earth emits has a longer wavelength, okay? It's a longer wavelength, so it's got less energy than the initial radiation that came in. So we're going to just make a note here that this is a longer wavelength. Or we could say a lower frequency wave. Now, the fun thing, or the interesting thing, is that, we'll call this step 4, much of the emitted radiation this longer wavelength radiation is trapped by the greenhouse gases. Okay, so the greenhouse gases are up here. And instead of those waves just going right on through, like the short wavelength waves, these longer wavelength waves are absorbed and then they're re-emitted. So much of the emitted radiation is trapped by the greenhouse gases, and then step 5, the greenhouse gases re-emit the energy, but not all of it goes out. So some of it now comes back this way. Some of it will go out, but a very low percentage of it goes out. It re-emits the energy, and much of that energy is sent down to the earth again. And so you can see then that those lower energy waves will be sent back down, absorbed by the earth, re-emitted, and then that bouncing back and forth between the earth and the atmosphere will keep that heat, that energy that was originally from the sun, it will kind of keep it underneath the blanket that is our atmosphere. Okay, as a result of all of this, the overall effect is that thing we call the greenhouse effect. That overall effect is that the earth warms over time. Okay. So as we said before, the greenhouse effect is not bad. In fact, without the greenhouse effect, we would not be able to be here because we need a little bit of that blanket to keep the earth warm, right? Otherwise, it would get really, really cold when we didn't have the radiation from the sun. But the game is that we have to have a really nice balance. So with the natural greenhouse effect, there's a balance of greenhouse gases like carbon dioxide and water vapor and methane and all the other ones that we listed. Okay, but there's a balance of those greenhouse gases, that are being released into the atmosphere through things like combustion and evaporation. Okay, and they're also being stored in reservoirs. Okay. And they're stored by things like oceans and trees, kind of like we talked about today when we were looking at those graphs. Okay. Water is kind of the great regulator of everything on Earth. This is what we were getting at earlier today when we talked about the evaporation cycle, right? It regulates all of the temps. At a manageable level. When it's allowed to. And the reason for that, remember from last unit, is because water, H2O, has a high heat capacity. Okay. Water also cycles in a short amount of time. Unlike things like carbon dioxide that take a little bit longer to go through a carbon cycle, we're talking about on the order of days for things like evaporation and condensation, precipitation, and all of that. Okay. Unlike water that does that cycle really, really fast, other greenhouse gases, okay, for example, carbon dioxide, they stay in the atmosphere for a long time. And by that I mean like hundreds to thousands of years. Okay. That means that when we throw more carbon dioxide into the atmosphere, it's just going to stay there and it's going to build up and build up and build up. And again, as we said earlier today and earlier in this unit, as we build up carbon dioxide, we get more energy trapped, which means that we have more water evaporate. And more water evaporated means more energy trapped. Okay. We can't change the amount of water vapor. That is the same amount that's always been on the Earth. That's all good because it goes through the water cycle, as we said, really, really fast. But the greenhouse gas that we can control is, as we've said over and over and over, this thing called carbon dioxide. Hopefully that gives you a little bit of a better sense of what is going on with greenhouse gases. Let me know, as always, if you have questions. Thanks, guys.